The most important point is the analysis. On the far left of the graph, on the y-axis, you can see flow, temperature and pressure. Below, the measuring point, and on the right, the digital input. At the top, you can see the legend. To display your values, go to Settings and select the desired input. Via the drop-down menu, you can set the graph's interval speed. For example, if you connect an injection molding machine to the I and O port of the D system, you have the possibility to synchronize your process by activating the digital input. If the input signal is too short, you can extend it. You also have the possibility that the graph stops as soon as the signal drops by activating this option. To go back to the analysis, click on the arrow. To start the short analysis, press the pause button. To set the wished analysis range, move the cursor to the start position and press the left save button. Then move the cursor to the end position and press the right save button. The analysis range is now set and can be deleted if necessary. To view the results, press this button. Now the minimum, average and maximum value of each measuring point are displayed. For a detailed analysis over a long period of time, we go back to the graph settings. In this menu, select Log. Now you will see the data log configuration screen. To save the data, connect an USB stick to the USB port. Cancel the appearing message. Define your interval speed between 200 and 60,000 milliseconds. Start the record by pressing Start icon. As long as you see the save symbol, logging is active. If you want to stop the logging, simply press Stop. It is important that you eject the storage medium properly, otherwise all saved data could be lost. To check the stored data, stop logging, eject the USB stick, and double-click on the file. This file's title is composed of Hotset, date and time. You will see logging date, time code and measuring values, but also synchronization, limits and errors. If any of the last mentioned values change, it will be marked with 1. In this example, a mold circuit was connected to our D system via the digital input and has been logged for 1 cycle. Here you can see the synchronization signal with our D system. The heat transfer in the mold increases the return line temperature. Shortly after the flow stopped, at the same time, the supply pressure P1 increased and P2 collapsed. As soon as the flow was restored, accumulated energy in the mold resulted in a return line temperature peak. The reason for that could be a kink toss of a moving plate in the injection machine.